Have you ever wondered where the water goes after a rain shower, or how plants get their water from deep underground? It all depends on how water behaves beneath the Earth's surface, specifically within two distinct areas. The key characteristics of saturated and unsaturated zones define how water is stored and moves underground. Simply put, the saturated zone is where all the pore spaces in the soil or rock are completely filled with water, while the unsaturated zone contains both water and air within its pores. The distinction lies primarily in the presence or absence of air within the subsurface pores. In the saturated zone, which lies below the water table, water fills every available space, effectively acting like a continuous body of water. This is where we find groundwater, which is a vital source for wells and springs. Water in this zone moves predominantly due to gravity and pressure gradients, a concept often described by Darcy's law. Above this is the unsaturated zone, also known as the vadose zone. Here, soil and rock pores are partially filled with water and partially with air. Water movement in this zone is more complex, influenced by gravity pulling it downwards and capillary forces holding it in place or drawing it upwards, similar to a sponge. Understanding these zones is crucial for effective water resource management and environmental protection. For instance, knowing the properties of the unsaturated zone helps us predict how quickly contaminants from the surface, like pesticides or industrial spills, might reach the groundwater. It also informs agricultural practices, as the unsaturated zone is where plant roots extract moisture. The saturated zone, on the other hand, is the reservoir, dictating the availability and quality of our groundwater supply. Its hydraulic conductivity, which is how easily water can flow through it, determines how much water can be extracted. Within these zones, you will encounter interesting phenomena like the capillary fringe. This is a thin layer just above the water table within the unsaturated zone where pores are saturated due to capillary action, but at pressures less than atmospheric pressure. Another important concept is field capacity, which describes the maximum amount of water soil can hold against the pull of gravity in the unsaturated zone. These nuanced details highlight the intricate balance of forces at play in the subsurface environment. Ultimately, grasping the differences between the saturated and unsaturated zones empowers us to make informed decisions about water conservation, pollution prevention, and sustainable land use. It clarifies how water cycles through the Earth's hidden plumbing system, ensuring we can better protect and utilize this precious resource for generations to come.
If you love learning about water, like, subscribe, and keep exploring with us.